Hi, this is Tim. Welcome back to the C++ Fundamentals VTC video training course. We're going to talk about user-defined conversion. Now, you already know about automatic conversion of types like integers to floats, floats to doubles, characters to integers, things like that happen implicitly and are performed by the compiler so that the correct work can be performed. If you multiply a character by an integer, we're going to promote the character, cast it up to an int, and then perform the work. Well, a user-defined conversion is when the compiler has no idea how to convert something to something else. Most specifically, how to convert a type to an object, and that's what we're going to do. The user-defined conversion lets you specify how an object converts either with constructors or with a conversion function. The user-defined conversions are implicitly used. They're not called like a cast would be. They are just used when they are used in code. And of course, we'll look at some code here in just a second to back this up and show you what I'm talking about. They're implicitly used in addition to standard conversions to convert initializers, function arguments, function return values, expression operands, expressions controlling iteration like in a looping environment, selections, and explicit type conversions. Now, like I said, there are two types of user-defined conversions. There's conversion by constructor, and then there's the use of a special conversion function, and we're going to look at both of those. Now, here's a converting constructor, and you can see this constructor is right over here, that we have a class Y, and here we have a converting constructor that has no code in it, neither one of these two. So if a integer I is passed in, we would return Y, and that would perform that conversion for us. And here this one takes a character pointer in and an integer and returns Y back. Then of course there's just another little method down here called add to do whatever it's going to do. That's just part of our class definition. So here, over here in main, we're going to be using this class, and just consider that this went on in one long list. I just can't show it to you on the screen in one long list. So here, Y of object 1 equal to 2 is the same thing as making object 1 equal to Y initialized with 2, and that since this is an integer coming in here is going to use this conversion constructor and take in the number 2 and then convert that to an object of type Y and return that. Here we pass in a string, Y of some string, and that's going to use our second converting constructor, our second method of construction. Again, here's the actual call, and this is what it really is going to look like it performs. Here again we pass a 10 into Y, that's an integer, so that uses this one, or object 1 equal to 10. It performs the same kind of functionality so that the number gets passed in and then the Y object is returned to object 1, and then the add of Y of 5 is that's what this is equivalent to, the add sub 5, and that's our little add method over here. We pass in 5 into Y, and since we have a Y object and we're creating a new one here, then our constructor runs, and since we're passing in an integer, we'll use this particular converting constructor. So a constructor is, the way it's built here, is always a converting constructor anyway, a constructor with a single input variable. Now let's take a look at a conversion function. So here we have an actual conversion function that is put into the class, which is created to perform specific conversion. This one is going to convert from an integer to our object. So here we have the class Y, and here is the definition of operator. That's the key word there, that we have operator, and that we're creating an int operator, so that's our conversion type, and that's the return of this will be the conversion type, and it will be returning back our integer b. These conversion functions take no parameters. There's nothing that can come in because of the way they work, and because of the work that they do, they are implicitly defined to return this operator type. So we know what comes out, we know that nothing goes in. Here, the f function down here is going to take in a y object, and we're going to convert it to an integer. And that is the whole function of this conversion function. That's why it exists. So here an integer I is equal to int of the object. We know the object is y. When this int gets used here, the compiler understands to come to y and look for an operator definition, and there it is, int. So b will be returned, whatever the value of that member b is. So that will come back into I. J, here we have an int cast of the object. Casting the object to int does the same job, finds the int, returns b. And here we do an implicit conversion of I, which is an integer, being added to an object. The object has to be cast or converted to an integer, and to do that we come and look for int, find b, add them together, and put it into k. So that's our conversion function. So now we know how we can provide our own user defined conversions, and that we have to provide them when the compiler would not otherwise be able to know how to perform the conversions.